My name is Gemmechu Mohammed. I'm a fourth-year software engineering student at Arizona University. Currently, I'm working at the University of Michigan as a research assistant with Professor David Foy and Christopher Rockwell. Our lab focuses on computer vision and machine learning, specifically on how to understand the world in terms of its physical property and functional property. I have been working on scene understanding using human accelerometer. Before I get into the details of the project, let's take a look at an example to help us understand more. What do you think the height of this car is? How about now? You see, it's a lot smaller than we thought, right? So what you did is, you estimated the depth and the scale of the car based on the person's size, and you give a reasonable estimate of the size of the car. This is exactly what we are trying to do with this project. So why is it important? Well, having a good depth knowledge system is vital for virtual reality, augmented reality, and many more. In addition to depth estimation, by looking at where people are walking, we could predict the floor of a scene, which is important for robotic navigation. Okay, let's get in the interesting part on how we solve this problem. But before that, let's take a look at our dataset. Our dataset is a 500 gigabyte of YouTube videos where people are doing day-to-day activities inside their home, inside their kitchen, their living room, The first challenge is floor prediction. In order to predict the floor from a person, first we need to predict the feet of a person. By assuming that people would walk on the floor, we used a 3D human mesh prediction. However, that did not give us a desirable output. So we used an open bow system to predict the ankle. By predicting the ankle for each frame in the video, we ended up with the floor mask. Next, in order to get only the static things in the video, we used a median algorithm to do that. Now we have the median image corresponding with the floor mask. And now we are ready to give training. We used a unit architecture with a RedNet backbone to do the segmentation. After training the model, we have now a floor prediction model. The other challenge is depth estimation, which means when the person is close to the camera, it will get hotter and hotter, and when we are away from the camera, it will get cooler and cooler, based on the person's height. We get the height by calculating from an ear to an ankle and dividing that with the picture's height to make it dimensionless across the video. By predicting the height for each frame in the video, we ended up with the depth map. Now we have the depth map corresponding with the median image. After running a regression model on this, now we have a depth estimation model. However, this needs a lot of work to make it accurate and robust. Finally, I want to talk about my experience in this program. I learned a lot about subject matter and research, and I met an amazing people along the way. Now on top of that, I read paper regularly, which is a good thing. Lastly, I want to thank my mentors, David, Chris, and all the people in the lab who helped me throughout the way. And of course, our members. Thank you very much.